2, 1. Action. Okay. Linear. If I were to take a linear function and put it on a graph, what would the graph look like?
A line.
A line. Very good. A linear function on a graph will make a line. And thank you very much for not yelling straight line. Okay, you don't need to say straight line. Lines are by definition straight. So a linear function on a graph will make a line. Okay? Now let's go to quadratic. Just so we get an idea of what these look like on a graph. So if I took a quadratic function and if I put it on a graph, what would it look like? A U, which is called a parabola. Excellent. So a quadratic function on a graph will make a parabola. And like a few of you accurately said, a parabola is a U-shaped graph, either up or down, but never sideways. Okay, and now exponential. Somebody in this class is going to have to dig deep into the catacombs of their brains. What will an exponential function on a graph look like? This is David Mojica world. Yes. It's like a nice smooth curve. Yeah, that never touches the x-axis. So, an exponential function, I guess it could touch the x-axis. An exponential function on a graph will make a smooth curve. That's actually the terminology you used last year in Math 1. Smooth curve. And if you forgot what that looks like, this is what an exponential function looks like on a graph. It would look like that. Right there. It's a nice smooth curve. Okay, guys? Or it could be like upside down. Or an exponential function might look like that. Okay? Either one. It could be other ways too, but that's the idea. It's a nice smooth curve. Alright, it could be like this one. Whoop! That's the name of that. That's what the sound that graph makes right there. Whoop! Or it could be like this one. Ooh. It's like whale sounds, you know? So I bet you guys, that's a linear, that's a quadratic, that's an exponential function, okay? Now, here's the problem. This is what they look like on a graph. How many of you guys actually have graph paper with you today? One of you actually have graph paper with you today. So either Gunnar is going to be nice enough to give out 37 pieces of graph paper, which I wouldn't do if I was him because graph paper is expensive, or you guys have to learn how to tell if something is linear, quadratic, or exponential without graphing it. All right? So here's what we're going to do today. We're going to figure out how can you tell if something is a linear or a quadratic or an exponential function without even knowing what the graph looks like. Okay? With only knowing values. So here we go. That's what we're going to learn how to do today. All right? So, let's say I have an x and a y table. I have a table of values. X values are 1, 2, 3, 4, and 5. And the y values are 2, and 6, and 18, and 54, and 162. All right? And you guys, I say, what type of function is this? Is that a linear function? Is that a quadratic function? Or is that an exponential function? All right? So, first of all, can you guys see why you wouldn't want to graph this? Yeah, I do not want to graph over 5 up 162. I don't even want to graph over 4 up 54. I would need a really big piece of graph paper to do that. Okay? So we want to learn how to tell what type of function this is without a graph. If you guys had to make a guess, what would you guys guess?
A line.
You guess a line, so linear? Exponential? Emily? Linear? Okay. Okay, watch how we do it. Okay, look at the x values first. What are the x values changing by? They're plusing 1 every time. Okay, notice, to get from 1 to 2, we're plusing 1. To get to 2, from 2 to 3, we're adding 1. 3 to 4, we're adding 1. 4 to 5, we're adding 1. Okay, so you guys, we would say that the delta x is plus 1. Okay, this triangle with the x, do you guys remember seeing this last year in Math 1?
Yeah.
Okay, they called that delta x. The triangle is a Greek symbol for the word delta, and it means basically that the x's are changing by plus 1. All right? Does anybody see the pattern that the y's are changing by? Gunner. Multiplying by 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So we would say your delta y is equal to, your delta y is times 3. That means my y's are changing by multiplying by 3. All right? So, you want to know what type of function this is? This is a exponential function. Okay? Number 1 is an example of an exponential function. Everybody understand why? Liars, none of you understand why. Because you're multiplying instead of adding or dividing. Alright, you guys? What are you multiplying? The delta y or the delta x? So, it's an exponential function if the delta y involves multiplication or what's multiplication's close relative? Division. Okay? Christina? I thought the air conditioner was on. It's really not cooling down, so I don't think the school has switched over to the air conditioning unit yet, so it's probably the heater. We'll turn it off. Okay. So you guys, what's the bottom line? How do you tell if something is an exponential function? What will the delta y involve? Multiplication or division. And by the way, they all need to be the same.
Yes, sir.
So it can't be like times 3, times 7, times 8, times 9. It has to be multiplication or division of the same amount. What?
It's like that, but it's irregular.
Yeah, if it's like that, it's like an irregular, weird-looking thing. All right, next one, number 2. Okay, and by the way, if you have graph paper, you are more than welcome to plot these points and connect them and see if they make a line or a parabola or a smooth curve. Okay, but you can do this without graph paper. Okay, number 2. I'm going to give you the same exact x values, 1, 2, 3, 4, 5. And then, but the y values are going to be slightly different. Okay, whoops, sorry. So the first y value is 2, just like the previous problem. The second y value is 6, ironically, just like the previous problem. The third y value is 10. The fourth y value is 14. And the fifth y value is 18. Okay? So the first thing we do is we look at the x's. What are the x's changing by? So delta x is plus 1. Okay? Plus 1. Their x's are all going up by 1s. Then you look at the y's and you try to find the pattern. Anybody see the pattern on how I'm changing the y's? Right, you're plusing 4. You're adding 4 every time. 2 plus 4 gives me 6. 6 plus 4 gives me 10. 10 plus 4 gives me 14. 14 plus 4 gives me 18. So we would say your delta y is plus 4. So does your delta y involve multiplication or division? No, absolutely not. So we know it's not exponential. So that means it's either linear or quadratic. Which one would you guess it is?
Linear.
This one's linear. Okay? So number 2 would be an example of a linear function. So what does that mean? If I put these points, this data, on a graph, would all the points line up in a line?
Yes.
Yeah, they would. Okay, so this is a linear function right here. Okay? How do you know?
If delta y involves addition or subtraction.
Yep. So it's linear if the delta y involves addition or subtraction. You know what? I'm going to add a word. It's linear if the delta y involves a constant addition or subtraction. Do you guys know what I mean by a constant addition or subtraction?
It doesn't change.
Right, it means it doesn't change. I should have put that word in for the first one too. Okay? But that's how you tell. If the delta y involves a constant addition or subtraction, means it doesn't change, then we have a linear function. All right? Number 3, what do you guys think number 3 is going to be? Man, you guys are so smart. It's going to be a quadratic. Let me show you why. Number 3, let me show you what a quadratic looks like on a table. Okay, so I'm going to use the same values again, 1, 2, 3, 4, and 5. First y is 4. Next one's 7. Next one's 12. Next one's 19. The next one's 27. Okay? So what are your delta x's? 1. You guys, delta x is not always 1, but delta x here is plus 1. When delta x is plus 1, it makes it really easy to see. Sometimes delta x mixes it up. Okay, but now, anybody see the pattern with the y's?
There's 2 patterns.
What do you mean by there's 2 patterns?
There is 2 with that increasing.
Well,
Y equals x squared.
That one's going up.
Right.
By how much?
3.
3. The next one's going up by what? 5. The next one, 12 to 19, is going up by 7.
That's what I meant.
The next one, 19 to 27, is going up by how much? How much? Really? 8?
9.
Oh, wait, I messed up on this one. That should be a 28. My mistake. So it should be going up by 9. My mistake.
But the other pattern is
I feel bad. So you guys, what's the delta y? Okay, well, first of all, is it a constant? No. So it involves addition, but it's not constant. So could it be linear? No. Okay, but here's what you do. Watch this. This is cool.
make a pattern.
We are going to look at the second delta y. So this first one is your delta y, but then we're going to look at the second delta y. Okay? 3 to 5 plus 2. 5 to 7 plus 2. 7 to 9. Those are all the same. Okay? So the second delta y is equal to plus 2. And they're all the same. So this would be a quadratic function. Okay? Okay, guys? Quadratic function. How do you know if it's a quadratic function? First delta y will not be a constant. Second delta y will be a constant. Okay, so it's a quadratic function if the first delta y is not constant, but the second delta y is a constant involving what? Addition or subtraction. Okay, addition or subtraction. All right, you guys? So there's kind of the hint on how you tell if data is exponential, linear, or quadratic.